In this example, we want to evaluate the following inverse trig functions. Let's look at part A. In part A, we want to find the cosine inverse evaluated at -1/2. We'll set this equal to y. Now, by definition of an inverse function, this is the same thing as saying -1/2 is equal to cosine y. So really the question that we're trying to answer is, what angle y, when we input it into cosine, gives us -1/2? Well, we can form a right triangle. And by definition of cosine, the sides of our triangle are going to be given by adjacent divided by the hypotenuse. And we know furthermore that the range of cosine inverse is between 0 and pi. Since cosine is negative in the second quadrant, we're going to have a right triangle in the second quadrant, whose adjacent side is length -1 and whose hypotenuse is length 2. Where this is our angle y, and this is our reference angle y bar. Y bar, in this case, is equal to pi divided by 3. Since this is a 30, 60, 90 triangle, and the length of the opposite side is the square root of 3, this implies that the angle y is going to be 2/3 pi. Moving on to part B, we're trying to find sine inverse of negative square root of 2 divided by 2. We're going to set this equal to y. Again, rewriting this using the definition of inverse, we're looking for the negative square root of 2 divided by 2 is equal to sine of y, where we're looking for this y term here. Again, from this information, we can form a right triangle, and since the inverse sign has a range between negative pi divided by 2 and pi divided by 2, we're going to have a right triangle either in the first or fourth quadrant. Since this is a negative number, our right triangle is going to be formed in the fourth quadrant, which has an opposite side of square root of 2 with a negative in front and a hypotenuse of 2, which means the adjacent side has length square root of 2. And the angle here is going to be given by our reference angle, which is going to be angle y bar. Since this is a special right triangle, which is a 45, 45, 90 triangle, y bar is going to be equal to pi divided by 4. And since we're measuring our angle in the negative direction, our angle y is going to be equal to negative pi divided by 4. In part C, we want to evaluate tan inverse at 1. We'll set this equal to y so that we can rewrite this. Then using, again, the definition of an inverse function, this is equivalent to saying tan evaluated at y is equal to 1. Again, we can form a right triangle, and since inverse tan has a range between negative pi divided by 2 and pi divided by 2, we can form a right triangle in either the first quadrant or the first quadrant. Since our trig function has an output that's a positive number, we can form our right triangle in the first quadrant. So here is our angle y, and the opposite side has length 1, the adjacent side has length 1, and so the hypotenuse has length square root of 2. Again, this is a 45, 45, 90 triangle, where we have that the reference angle y bar is equal to y, which is equal to pi divided by 4. In this problem, we want to evaluate cosine evaluated at sine inverse of the square root of 3 divided by 2. And to solve this problem, we're really going to be looking for the solution of sine inverse of square root of 3 divided by 2, since this is going to give us an angle. Again, let's go ahead and evaluate the following. Since this is going to be equal to y, this is the same thing as saying the square root of 3 divided by 2 is going to be equal to sine of y. So what angle y makes this equation true? If we go ahead and draw a quick picture, we know that sine inverse has a range between negative pi divided by 2 and pi divided by 2, and sine's positive in the first quadrant. So we want to form a right triangle in the first quadrant. The definition of sine tells us that the opposite side of this triangle is going to have length square root of 3, and its hypotenuse is going to have length 2, and so the adjacent side has length 1, and this is going to be our angle y here. So we can go ahead and evaluate cosine at y here, and cosine is again defined to be the opposite side divided by the hypotenuse, and we get that this is just equal to 1 divided by 2. In this last problem, we want to evaluate sine at tan inverse of negative square root of 3. The first step in this problem is, again, we want to find the angle of tan inverse when we evaluate at negative square root of 3. Rewriting this as a function of tan, this is going to be the same thing as saying the negative square root of 3 is equal to tan evaluated at y. Again, the range of our inverse function is going to be between pi divided by 2 and negative pi divided by 2. And since tan evaluated at y is a negative number, we want to form our right triangle in the fourth quadrant. And the opposite side has length negative square root of 3. The adjacent side has length 1. And so we see that this is going to be a 30, 60, 90 triangle, which means the remaining side has length 2. Now, the angle here is going to be our y bar. And so we want to evaluate our sine at this reference angle y bar. And this is going to be equal to the negative square root of 3 divided by 2.